Hello everyone. This is part 2 of our review for unit test number 5. We finished off with our factoring problems and now we're going to solve some quadratic equations. The first two examples, A and B, have situations where the left-hand side is already factored for us. That is, we generally have the form ax squared plus bx plus c equaling 0. And it's factorable into the product of two binomials, as letters A and B already are, and then we use the zero factor property. And the zero factor property is that if A times B equals 0, not referring to the A's and B's here, but if any product of two things are 0, then A equals 0 or B equals 0. So using the zero factor property, we're going to set each factor to 0. So x minus 7 is 0, and we typically draw a line and then set x plus 5 equal to 0. So notice how now we have two linear equations, and we solve each of those. So here we'll add 7 to both sides, and we get that x is 7. Similarly here we'll subtract 5 from both sides, and we get that x is negative 5. So as a solution set, if you wanted, 7 and negative 5. No particular order could list negative 5, 7 as well. So here's the same idea. It's already factored as the product of two binomials. So we set each factor to 0. 7x minus 5 is 0, and 8x plus 3 is 0. Solving each one of those, first we had, for the first one here, we'll add 5 to both sides. We get 7x equals 5. And then finally dividing by 7, we get x is 5/7. And for this one, we first need to subtract 3 from both sides. You could show that or do it mentally, transpose it mentally. And then finally the division. And feel free to skip as many steps as you like. And we get x as negative 3/8. So in my math lab, sometimes it says list them as a solution set, or maybe separate them by commas. But as a solution set in braces, 5/7, negative 3/8. Okay, but now we have the standard situation where we first have to factor. First, make sure it's in standard form. Everything to one side set to 0. It's quadratic because we have a squared term. Factor is the product of two binomials. Make sure your rate equals 0. We know it's going to be an x and an x. You could list the factors of 32, but here I'm going to use trial and error. I know both signs are negative because the product's positive and the middle term is negative, and it looks like a 4 and an 8 will work. So then if we set each one equal to 0, again you could do this mentally, but if you want to show it literally, add 4 to both sides. We get x is 4 here, add 8 to both sides, and we get that x is 8. So again, as a solution set, 4 and 8. Okay, another example where again it's in standard form. It's a quadratic trinomial. Factorable is the product of two binomials. Leading term is x squared, so put an x and an x. Okay, I know one sign's positive and one's negative. And if you want to go so far as to show the factors of negative 24, I could have done that here, but I did that one mentally. But showing it literally here, 1 negative 24, negative 124, 2 negative 12, negative 2 12, 3 negative 8, negative 3 8, and 4 negative 6, negative 4 6. That's all the factors of 24. The pair that combines to a positive 2 is negative 4 and 6. So it's a positive 6 and a negative 4. So I had already put the signs in there, so I had to make sure it's set up correctly. Should have wrote equals 0, because now I set each factor to 0 by the zero factor property. So x plus 6 equals 0, x minus 4 equals 0. Solving each of those linear equations separately. Get x is negative 6. Here I'm showing all the steps again. And x is positive 4. So negative 6 and 4 as a solution set. Okay, this only has two terms, but it is quadratic. So first thing we look for is the greatest common factor. And that's x in this case. So factoring out an x, reversing the distributive property, x times x gives the x squared. To generate the second term, we'll need a minus 9. That's set to 0. Right, let me just take those arrows out of there. I'll just recopy it. And now we set each of those factors to 0. So x equals 0 is a solution, and then x minus 9 equals 0 is the other solution. But we need to solve that second one, and we get that x is 9. So the solution set there, 0 and 9. Now this one has a quadratic because it's squared, but it's not in standard form. So let me rewrite it here. X squared is 36. We have to set it to 0, so we're going to have to subtract 36 from both sides. Now you can mentally transpose, or just realize, of course, that x squared minus 36 cannot be combined, and that's set equal to 0. And now it's a quadratic, but it's only two terms. If you look for a greatest common factor, nothing's in common, so you should recognize that this is the famous difference between two perfect squares, where it is factorable as x and x, one negative, one positive, and 6 and 6. So setting each factor to 0, x minus 6 is 0, x plus 6 is 0, and solving each of those, we get x equals 6. Here subtracting 6 from both sides, x is negative 6. So then, again, as a solution set, 6 and negative 6. Alright, so the final page is a few more equations and then a word problem. And once again, we have to have standard form, everything to one side set to 0. Let me just show this by a mental transposition. I'll just show that I'm moving the 21 to the left. So this becomes x squared minus 4x minus 21 equaling 0. So when we cross the equal sign, remember the term changes sign. And then we'll factor that as normal. Sorry, my dog. Okay, so get an x and an x. Looks like one negative, one positive, because that sign of the constant term is negative. And I think we're going to go with a negative 7 and a positive 3. And you could check that. And then setting each factor to 0. X minus 7 is 0. X plus 3 is 0. Again, feel free to solve these ones mentally. If you want to show them literally, x is 7. And looks like x is negative 3. When you write the solutions, they do not have to be in any particular order. It could be negative 3, 7, 7, negative 3. Does it not make a difference? And then here's a special one where it's a cubic equation, but we have it in standard form. Everything's on one side set to 0. And the first thing we should look for is the greatest common factor, which in this case is x. And if we factor out an x, I'm going to reverse the distributive property. I'll have three terms in parentheses. To generate the first term, I need an x squared. To get the second term, negative 11x. And to get the third term, just plus 10. And that's set equal to 0. Alright, so let me recopy that and get the arrows out of there. And notice now that x is a factor, so that has to stay. But this x squared minus 11x plus 10 is a quadratic trinomial, which should be factorable as the product of two binomials. And we'll need an x and an x. Okay, I'm going to use trial and error here. You can list the factors if you like, but using the trial error method, I know both signs are negative because the constant term is positive and the linear term is negative. And it looks like a 1 and a 10. It's actually going to work. So now there's three factors set to 0. X minus 0, or excuse me, x equals 0, x minus 1 equals 0, and x minus 10 equals 0. 0 is a solution. Here we'll have to solve by adding 1 to get that x equals 1, and here we solve by adding 10. So x equals 10. So this solution set has three solutions, 0, 1, and 10. And then finally the last problem, oops, sorry, I didn't see that at the end there. Last problem, a little word problem. You don't have to know the physics, but all you do have to know is that the scenarios of building, let me just draw a little building here. Here's ground level, put a little door, a couple windows maybe. But I'm throwing a ball into the air or some object, goes into the air, reaches its high point, comes down, hits the ground. Now, the idea is that this building is 144 feet tall, but when it hits the ground, the height is 0. And notice how this given equation is the equation for the height. So, sorry you didn't see me draw the picture, but there it is. You can take a second to write that down if you like. But the idea is that when this object hits the ground, this equation is going to be equal to 0 because h is 0. So 0 is equal to negative 16t squared plus 128t plus 144. Now, if that bothers you that the 0 is on the left, just change it. Minus 16t squared plus 128t plus 144 equals 0. But now these problems are designed so that whatever the leading coefficient is, which in these examples will always be negative 16 because that's 1/2 of gravity, the acceleration due to gravity that is, negative 16 will be common to every term. So what you could do, and that's just by design, in real life it doesn't work that pretty, but what you could do is just divide everything by negative 16. So be prepared to see the exact same type of situation. And if you have to, use a calculator. The negative 16 divides out just to get t squared in the first term. Negative 16 divides into 128 negative 8 times, so minus 8t. And negative 16 divides into 144 minus 9 times. And then 0 divided by negative 16 is 0. And then we factor. We're going to need a t and a t. It's a standard quadratic. Looks like a plus and a minus. And if we make the 1 positive and the 9 negative, there's the correct factorization. Set each factor to 0, so t plus 1 is 0, and t minus 9 is 0. And now when we solve each of these, we get t equals negative 1 and t equals 9. But the negative number doesn't make sense in terms of the physical situation. So recall this is, use the fancy term, extraneous. So t equals 9 is our solution. So you can say t equals 9 seconds. Okay, so that's the end of the review for unit test number 5. And as always, good luck, and let me know if you have any questions or concerns.